Next, we have cubics. Cubic function, f of x is equal to x cubed. Cubic functions have x's be our variables being cubed. The verbal description is the volume of a cube is equal to the product of the dimensions. Again, this is kind of a convoluted verbal description. But what this means is, if we have a cube, like this, if we have a cube, and we know a cube has all sides equal, so our dimensions are x, x, and x, a cubic function is equivalent to the area of a cube. Oh, sorry, area of a cube, my gosh, volume. We know volume we find by multiplying the length times the width times the height. So in this case, our volume is equal to x times x times x, which is x cubed. So a cubic function is a representation of the volume of a cube. And here's our table for cubes, the parent function of a cube. Again, we're taking our x values, our input, and cubing them to get our output, our f of x values. So negative 2 cubed is negative 2 times negative 2 times negative 2, which is negative 8. And negative 1 cubed, negative 1 times negative 1 times negative 1 is negative 1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. That is our table for the parent function of a cubic. And then they just took that table and they graphed it here. We'll graph some of the points here. They graphed the, if you recall, inflection point. That's the center, the change in direction of your cubic right there, 0, 0. And they also graphed 1, 1 and negative 1, negative 1. Remember, cubics form like this S shape. So that's it for cubics. We have the verbal description, the table of values, and also the graph.